Okay, here I am back just with another example of using the law of cosines. It's going to look much like the second part of the last example we did in the previous video, with a couple other helpful hints via audio here. So we have triangle ABC with all three side lengths being given to us. Our job is to find the measure of its angles, something that in a strict geometry class you would not be able to do. So some triangle, and I don't really know what it looks like. It's not really terribly important. So triangle ABC, where side A is 90, side B is 70, and side C is 40. Clearly, this diagram is not to scale as 90 is the longest side, but on my diagram, it is the shortest side. But that's not really important. It's the idea. One good idea, though, when using the law of sines or the law of cosines, it doesn't matter which one, when you have to find an angle, try to find the largest angle first. A triangle can only have one obtuse angle. So by finding that largest angle first, you can do things to avoid the ambiguous case with the law of sines and some other troublesome work that can happen. So first piece of advice, always try to find the longest side and the longest angle first. So for me, that means I'm going to be looking for angle alpha, meaning I'm going to use the version of the cosine function a squared equals b squared plus c squared minus 2bc cosine alpha. And this is going to look like, and that's not coming out very nice for me, 2bc cosine alpha. So it's going to look very much like what we did in the second part of the example in the previous video. Maybe you want to pause the video here, see if you can do it yourself, and then come back and watch the solution. I would start by substituting values in here. So I'd have 90 squared equals, let's see, 70 squared plus 40 squared minus 2 times 70 times 40 cosine alpha. And those are big numbers, and honestly, I don't even want to deal with them. So I'm just going to rewrite them as is. I'm going to subtract the 70 squared and the 40 squared from both sides. 90 squared minus 70 squared minus 40 squared equals negative 2 times 70 times 40 times cosine alpha. This little piece right here, yeah, that would simplify down to some number, and I could figure it out, but honestly, I'm not going to bother. I just know that whatever number that is, I would divide both sides by it. So that is going to give me 90 squared minus 70 squared minus 40 squared over negative 2 times 70 times 40. The calculator can do that work in a minute. I can just write it, giving me cosine alpha. To find alpha, I'm going to need to use the inverse cosine function. So the inverse cosine of this whole big expression, 90 squared minus 70 squared minus 40 squared over negative 2 times 70 times 40, too many parentheses, times 40, will give us our alpha. Like I said in the last video, this piece right here, you can simplify that ahead of time, or you can enter it into your calculator as one big expression. That's really your choice. At the end, though, we're going to get alpha equals approximately 106 degrees. Well, looking at my calculator, I guess it's closer to 107 degrees. So now we have alpha is 107 degrees. So that's that. I know that I can label that here. Alpha equals 107 degrees. And at this point, you can either use the law of sines to find a second angle, or you could use the law of cosines again. And you could use that law of cosines in a couple of different ways. I could use all three sides to find another angle, much like I did in the particular case that we just finished. Or I could use the law of cosines more traditionally now that I have two sides and the included angle. Or I could use the law of sines. I have a complete ratio. Knowing side A and angle alpha, I could use the law of sines. So when you're working with a problem in trigonometry, at this point, this particular problem has 3 different methods for finding a second angle. I'm going to go with using the law of cosines, using the 2 sides and the included angle to find the side. Oh, but I already know the side opposite, so I'm actually not going to do that. So 2 methods, law of cosines or law of sines. I'm going to use the law of sines because it's easier, little less work, and I've already dealt with my obtuse angle, so I should be able to avoid the ambiguous case. So I'm going to say sine of 107 degrees over 90 is equal to, and it doesn't matter what I choose here. I'm going to go with sine of gamma over 40. A little bit of algebra, I get that sine of gamma is going to be equal to 40 sine 107 over 90. Let me shrink this down so we can see it a little better. Inverse sine function of 40 sine 107 degrees over 90 will give us our gamma. Take a moment, put that in our calculator, and we get approximately 25 degrees. So that's just using law of sines within a law of cosines problem. And that's how a lot of this trig stuff works. While it's a law of cosine to start, the finishing of the solution can meander through a couple of different methods. So we've got our alpha, we've got our gamma. Oh, maybe I'll label that on our diagram. Gamma equals 25 degrees. I'm just going to get this all out of the way. Didn't quite get everything. I don't seem to be able to grab with any degree of accuracy at the moment. Let's grab that. There we go. And just slide it over to the side. And then to find the third side, we're just going to use the angle sum formula. I have a total of 180 degrees. I've used up 107 for alpha, another 25 for for gamma. So that's really going to give me 180 minus 132 degrees. That's going to leave me with 48 degrees. So beta is going to end up giving us about 48 degrees. So there's a second example on how to use the law of cosines, how it interacts with the law of sines, et cetera, et cetera.